Hi, I'm Carl Morris from Bez IT. I'm here to talk to you today about SD-WAN as an introductory high-level overview. Thought I'd start by just giving you some information about what software-defined as a concept is. Software-defined describes intelligent programming to control and manage the software and hardware components of a given IT solution. What this does is give you greater visibility across these components, more flexibility in the programming of them, reduce complexity when designing these solutions. And the end result is designed to give simplified management and control for IT administrators, so you can spend more time on other tasks. Software defined as a concept has already penetrated the storage world, the compute world, and the networking world. And what we'll focus on today is SD-WAN, which is a part of the SDN, software-defined networking concept. One of the biggest features of SD-WAN is link aggregation and management. Here you have your SD-WAN router, and what you can do is you can add in your NBN connection, a fiber service, or even connect an MPLS to it, and basically aggregate those links together to give you the expected performance. You can also have 4G as part of this mix. What this does with your bandwidth is it is designed to basically smooth out the fluctuations in performance on your links. So for example, if you had an issue where, say, your primary connection went down, 4G bandwidth could be injected to take over, and this is active, not passive, unlike typical MPLS networks with an XG backup. Along with link aggregation, another main benefit of SD-WAN is traffic management on your network. Typically, when you designed your network, you would basically program these links to have enough allocated bandwidth for the entire traffic that will go across the network. With SD-WAN, because you have multiple links going into the site, you can have breakout points at the router out to the internet. So what does this mean? All your corporate traffic that runs along these links can be kept on your primary connections. However, if you have users that want to break out to things like Facebook or YouTube, they can go directly out to the internet and not affect your corporate network, maintaining the integrity of your core applications. So how does SD-WAN compare versus traditional MPLS networks? With MPLS, you had to program these routers out to the edge of the network to maintain traffic priority between the network points. These routers are often difficult to program. There are very long lead times for these networks, up to 90 days in some cases. The design of the MPLS programming would give you limited visibility across the network. It is built on expensive technology. Typically, when you're designing an MPLS network, you had to stick all of your carriage with the one provider. Also, at present, MPLS networks provide mostly passive backup in the case of a link failure. With an MPLS, you effectively programmed data at one point as it travelled through the network, and then the tag was removed at the other point. SD-WAN does this differently. It looks at the application profile, and at an application layer will prioritise the traffic it needs. It doesn't exactly give you quality of service in the form of packet tagging. However, you can use the links, and remember, you can have multiple links bonded to give you the application performance that you want, even for real-time applications. Another key benefit of SD-WAN is rapid deployment. Remember, I mentioned long lead times on MPLS networks previously. Because the intelligence is built into the router and it understands what applications you're using and what type of design on the network you have, these can be pre-configured and shipped to site and use whatever links you have available at the time. So for example, you could have an NBN link connected first whilst you wait for a fiber link, and you can still get similar performance at best efforts. If you needed to inject more bandwidth, you could have a 4G service that will take over if the NBN service degrades to a point that it is not giving you the application performance you want. Also, with MPLS networks, you can put the SD-WAN routers on top of an MPLS network to give you rapid deployment. This can also be used to slowly migrate from MPLS to SD-WAN. If you still need QoS tagging on your network, you can keep your MPLS links, but you can scale them down as required for those real-time services. In summary, SD-WAN gives you a lot more flexibility in designing a corporate network, even with multiple link types. And with those multiple links, you can reduce the complexity of the network because there is an intelligent programming layer in the design of the solution. You can still have comparable performance to quality of service and packet tagging if you wish through application profiling, or you can still have MPLS underpinning your SD-WAN. SD-WAN also gives you rapid deployment options with pre-configuration, so you can use the quickest links available to tunnel back into your corporate network. So what does all this mean? It really comes down to how you want to design your network and the benefits that you want to achieve, whether it be a cost reduction, a performance benefit, breaking out internet-facing traffic to corporate traffic, or network agility. SD-WAN is designed to give you a combination of these things and will allow you to build and design your network how you choose. I've touched on some of the key points of SD-WAN, but it's important to note that there are multiple technologies out there and multiple products, and some of them will handle some of the benefits a little differently. So it's important to talk to someone who understands the technology, where the gaps are within certain products to help you design your network. I'm here to help if you need me. Thank you for your time.